Okay, when spatially, if you can minimize this kind of region smaller and smaller, we get into what is called as a um, sampling at a high rate. Sampling at high rate on a smaller area, for example, will give more details about the image. So we want to know whether image has got completely correct details or only an approximate detail. An approximate detail will result if you're taking images of long distance. For example, if you really look at taking an images through a satellite, for example, satellite take images on Earth, of the Earth, right? So typically one satellite image will cover something like 1 kilometer by 1 kilometer, right? Assuming that 1 kilometer, so 1,000 meters it covers. And for example, if the image has digitized at a rate of some 1,000 by 1,000 pixels by 1,000 pixels. Now each pixel will cover an area of 1 kilometer. Okay, 1 kilometer area. I'm sorry, 1 meter area. So 1 meter is 1 meter by 1 meter is basically covered in 1 pixel. Details of 1 meter by 1 meter is covered in 1 pixel. So, for example, within 1 meter, I mean, in a square area of 1 meter, many things could have happened, right? There may be, for example, two objects of 50 centimeter lying in this. So, but however, this particular image can only combine these two objects and then call it as a 1 pixel. For example, one is completely, for example, 50 centimeters, you have one book, for example, a book of size. And then here you probably have your bag, okay, now next to each other. Then now it is difficult to see that, two objects present in this 1 meter by 1 meter area. So it will show either a book or for a bag or something. So it will the pixel is no longer, is approximating this region. So when it approximates the region, then it is kind of a mixed pixel. It has more information, but it has a mixture of two objects. So it's kind of a mixed pixel. So I mean, mixed pixel will result if you have too small sampling rates within the same region, right? So we won't have as many, for example, as many samples as possible with this mail. That is why it's called spatial sampling. There is also something called as the temporal sampling. You take sampling over time. So when you take sampling over time, it is called temporal sampling. I told you this essentially happens because that we have to we are doing quantization of pixel values. Okay, so there are continuum of pixel values. For example, if you look at any portion of the image, for example, this is called as a grayscale image. Why it's called a grayscale image means that it has both shades of varying intensities between black and white. So there is a perfect white somewhere, there is a perfect black somewhere, and there are regions which probably combination of black and white. So it's called grayscale. Now a mixture of colors is known as red, green, blue is a color image, right? A combination of this. So you will have, for every component, you will have 3 values per pixel, right? So 3 values per point per pixel. So again, you will have one more RGBA is a kind of another system where most prominently we use either RGB or grayscale. The problem is like, image is a discrete function. Image is a discrete function.